Good morning to all of you. In this video lecture, we are going to see the topic resolution of forces, video lecture 1. The subject name is Engineering Mechanics, the subject code is G8292. Myself, K. Rajasuthan, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering Technology. Let's go to the slides. Now we will move on to the first problem. I will read out the problem first. An eye bolt is being pulled out from the ground by three forces as shown in figure. Determine the equilibrants on the eye bolt which resist to come out. So what is called as, before going to the problem, we want to discuss one small thing, what is called as equilibrant. So you know what is resultant. A resultant is the single equivalent force which replaces all the other forces in the given system. Then what is called as equilibrant? Equilibrant is one which is has the same magnitude as that of the resultant but opposite in direction. That equilibrant only makes the system in equilibrium condition. So only it is called as equilibrant. Okay. So now are you able to understand what is called as equilibrant? Okay. Now we can go to the problem. So actually see the diagram. So the bolt is being bolted to the ground and three forces are acting. So one is 1000 Newton, that is perfect horizontal force, and the second one is 2000 Newton force which is acting in the first quadrant, which has both components positive, and the third one is a 3000 Newton force which is acting on the second quadrant, which vertical component is positive and horizontal component is negative. And the angle of the two forces are not given, but instead of that they have given the slope 3 by 4 and 4 by 3. Okay, with the slope we can find out the angle of 2000 Newton force and 3000 Newton force first. Solution. So first of all, with the help of the slope, we are going to find out the angle of the two forces. First, for a 2000 Newton force, we are making the angle that is tan Q1, that is theta 1 is equal to 3 by 4, which implies that Q1 is equal to 36.87. The 2000 Newton force is making angle 36.87 with respect to the x-axis. Next, we can come to the second force, 3000 Newton force. For that, the slope is 4 by 3. So you apply tan theta, tan theta 2, that is Q2. Tan Q2 is equal to 4 by 3, which implies Q2 is equal to 53.13. The 3000 Newton force is making angle 53.13 with respect to the x-axis. Okay. So now we can resolve the forces horizontally. Okay. So before that, if you want to draw a split up diagram also, you can draw with the help of the 2000 Newton force and 3000 Newton force, which has two components. Okay. Then we can solve the horizontal components as follows. Resolving the forces horizontally, we get Sfx is equal to the 1000 Newton force has only one component, it's purely horizontal. So 1000 positive plus 1000 plus 2000 cos 36.87 minus, because it is in the second quadrant, becomes minus 3000 cos 53.13. So solving these things, we get Sfx, that is the horizontal component summation, is equal to 799.99 newtons, that is equal to 800 newtons. In the next step, we can find out the summation of the vertical components, that is sigma v. Okay. So resolving the forces vertically, we get Sfy, that is, we can also term it as sigma v, is equal to both the forces 2000 and 3000 newtons are acting in first and second quadrant. So it is having vertical component positive. So it will give the values of 2000 sin 36.87 plus 3000 sin 53.13. Okay, solving this equation, we get the vertical component summation Sfx is equal to 3600 newtons. That is the answer for sigma v, that is the summation of vertical components. And the third step in the resolution of forces is finding out the magnitude of the resultant. So for that, we know the formula R is equal to root of sigma h square plus sigma v square. So substituting the sigma h and sigma v values here, we get R is equal to root of 800 square plus 3600 square. Simplifying this, we get R is equal to root of 3687.82 Newton. That is the magnitude of the resultant. Now we want to find out the angle of inclination of the resultant or direction of the resultant, alpha. Here it is mentioned at Q. Okay. So we know that alpha is equal to tan inverse of sigma v by sigma h, which implies alpha is equal to tan inverse of 3600 divided by 800. Solving this, we will get the value of alpha, that is Q, is equal to 77.47 degrees. So actually we want to locate the resultant here. So since both the sigma h and sigma v values are positive, sigma h and sigma v values are positive, R is located in the first quadrant. So at an angle of 77.47 degrees, that only we have marked in the diagram which is showed in the top portion of this page. Okay, that is the location of the resultant. R is equal to 3687.82 newtons, and it is acting along the first quadrant because sigma h and sigma v are both having positive values. So it is located in the first quadrant. The angle of the resultant is 77.47. Next, you want to find out the equilibrant. Equilibrant is nothing but the force which is equal and opposite to the resultant, which keeps the system in equilibrium. Okay, that is opposite to the resultant force. So you can directly take it to the third quadrant, 77.47 degrees, and the equilibrant E is equal to 36.87 3687.82 newtons. Okay, it is directly opposing the resultant force which is causing the system in equilibrium. Okay, so that is all about the problem. Thank you.